Composition and recursive ACL. This article demonstrates a simple example of using recursive OCL within a composite pattern. To understand recursion, we must first understand recursion's source unknown. Surely there isn't a professional programmer out there who hasn't used recursion. I'd bet that the first recursive routine that most of those programmers wrote was some kind of find all files routine. The beauty of recursion is that it is so simple, yet the results give the illusion that the code must be far more complicated. I'm slowly rewriting www.howtodothings.com in my very little spare time. Before, the categorization of articles was 3 levels deep, no more, and no less: topic-category-subcategory. One of the improvements I have decided to add to the site is the ability to nest an unlimited amount of levels. To do this, I implemented a pretty basic OOP composite pattern like so. A base category is an abstract class. Its only purpose in life is to have a name and to own subcategories. A subcategory exists to own articles and more subcategories. A main category holds an image for the main page, and owns subcategories. My categorization can now consist of a minimum of 2 levels, main category-subcategory, or as many levels as I like. Next, in the model's base class, I implemented a derived attribute called displayName string. This attribute was initially added so that I could use a single web page confirm delete.aspx to display the name of the object the user wants to delete. This would typically be an article, but I can reuse it for any object at all. The code for this attribute is as follows: public string displayName derive and subscribe, iSubscriber reevaluate subscriber, iSubscriber resubscribe subscriber, i=service equals i=service, this.AsIObject. Service provider.getEcoService, type of i=service, return string, equal.evaluate and subscribe, this.AsIObject, self.asString, reevaluate subscriber, resubscribe subscriber, .asObject. It merely evaluates self.asString against the current instance. This has the effect of evaluating the default string representation OCL expression entered in the model and returning it as a string. Base category has its default string representation set to name. Now here is where the recursion comes into it. As I was entering a new subcategory, it didn't take long to realize that ASP.NET told me nothing about where in the categorization structure I was working. Wouldn't it be nice if instead of just seeing ASP.NET I would actually see computers-programming-Delphi 2005-ASP.NET? So that's what I did, and the beauty is that it didn't take a single line of code to work out the path, because I used a very simple recursive OCL expression. I added a new path, string attribute to the subcategory class, set derived to true, and then set the derivation OCL to parent category.displayName. Remember that displayName will just return the default string representation, so in this case the subcategory.path is just returning the displayName of its parent. This isn't any use at all, until you change the default string representation to, like so. Parent category.asString plus name. The display name of any category is its parent's default string representation and a separator and its own name. What is its parent's default string representation? Well, if the parent is a main category then the expression name is used. However, if the parent is also a subcategory then the expression parent category.asString plus name is used, all the way up until we reach the main category. Not only does this give me a very informative path attribute, but as a very pleasant byproduct, it also gives me the full path and name in the confirm delete.aspx web form whenever I try to delete a subcategory object.